Okay, we're going to have some fun now with two battleships and vectors and the software autograph. We've got two battleships. A is going at a speed given by a vector 1 minus 1, and B down here is going at a speed of 1.5 and 2. And the question is, when are they closest? Well, we can convert these velocities into displacements very easily. So if we just double click on that, so because distance equals speed times time, we just have to multiply each of these by t. So 1t is just t, and minus 1t is minus t, so that's that one. And this one, we do 1.5t and 2t. Now, autograph always takes new constants at a value of 1, so that's quite handy. And so it does look as though this is where the ships are going to be after 1 unit of time. So just to make a little bit clearer that the ship is where the end is rather than the beginning, that's where it was at time 0, I'm just going to make a little circle on this. That's off the bottom, so I'll use the object menu, which is always available, and circle and radius. If I go 0.2, that'll do that nicely. And likewise here, I'm going to do object menu, circle, radius, 0.2. Okay, now we've got our two ships. If we just use the constant controller now to increase t, you can see what's happening. But it's not terribly obvious when they are closest. So let's see if we can be a bit more scientific about this. I'm going to join these two together with a line segment. And then down here, I'm going to put a point, say here, it doesn't really matter where, and I'm going to select that point and this line segment, and I'm going to object menu, create a circle by center and radius. So this is a circle with a radius equal to the distance between the two ships. So if I play around with time now, it should be fairly clear when they are the closest, because that radius will get the shortest. Let's see about that. What do you reckon? Round about there. So it's not very obvious, but it's sort of round about 1.9 seconds. Maybe we can be a little bit more precise about this. Well, one way I always like to do relative velocity questions is to reduce one of the ships to rest. So I'm going to select this point and this vector and ask for a negative vector. So that's going to be minus whatever this displacement is. And now I'm going to copy this vector over to here and object menu, copy vector. So essentially, if I add these two together and put the answer here, right click, add vectors. This is the direction that boat A sails, assuming that B is at rest. So that's the relative direction of A to B. Okay, so what we want to do is find the point where it is at the closest distance, and that's going to be when the perpendicular distance from here to there meets the direction of A. So let's just select this point here and this direction vector here, and do a right click or object menu, perpendicular line. Now if you want to make that line a little bit dotted, for example, you select and right click, edit, draw options, and make it dotted. There we go. So what we've got to do now is change the value of t until we hit this dotted line. Now we're going to have to reduce the step and come back a bit, and there's the answer, round about 1.83. If you want it a bit more accurately, you can zoom in, of course, zoom, 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 and you can see that actually it hasn't quite made it yet. So we can reduce the step again and go the other way until we just get closely. So reduce the step and back we come, round about 1.8376 to 5 sig fig, so that's pretty good. So there you are. It's a great topic. It's a good way of making students realise that actually vectors can be a lot of fun and really quite useful.